Hi, welcome to Craft Beer and Brewing's course on building, maintaining, and troubleshooting your home draft system. My name is Dave Carpenter, and I am a contributing editor for Craft Beer and Brewing magazine. And in this course, whether you're a home brewer or just a beer enthusiast looking to maintain your own kegerator, we're going to teach you everything you need to know so you'll feel comfortable at the end of this assembling or disassembling your home draft system. If you are a home brewer, maybe you're already kegging your beer and you want to have a way to serve it. Maybe you're a beer enthusiast who would like to build your own home kegerator, or maybe you already have a kegerator and you want to add additional lines or maybe upgrade it in some way. We're going to show you everything from the gas side to the liquid side so that you can avoid foaming issues. You can understand everything you need to know to pour the perfect pint from your home kegerator. Just as with beer brewing that there's a hot side and there's a cold side, it helps to think about draft systems as having a gas side and a liquid side. The gas side is everything, what you might say, upstream of the keg that involves putting gas into the beer and pushing it. And the liquid side is everything downstream of the keg to the faucet that involves getting the beer out of that keg and into your glass. So we're going to describe both sides of this today, tell you how to optimize both. Let's go through a few of the components that we're going to use in this. I'll start with the gas side. So you will have, whether you're a home brewer or a commercial brew purchaser, you will have a keg, a home brew keg. This is a pin lock keg, and we won't really go into how to keg your beer in this episode. If you're interested in learning how to keg your beer and understand all the details of disassembling and maintaining a keg, then definitely check out our online course on kegging. This is a pin lock keg. It has a liquid out and a gas in, and it uses these kinds of disconnects, gray for gas and black for beer. And with a pin lock keg, there's no chance of putting the wrong one on the wrong post. If you use ball lock kegs, they look very similar. Uses these kinds of disconnects, and it is possible to put the wrong disconnect on the wrong post, but you'll only do that once. Then, if you aren't a home brewer, or maybe you're just looking to put some commercial beer in your kegerator, this is the type of keg you'll be using. It's called a Sankey keg, and this is the one that all the pros use. There's a special coupler that goes in here that provides both gas in and liquid out using the same device. The kegerator that we're going to describe actually will allow you to use either type of keg. So we've designed this course to teach you how to build the most flexible and maintain the most flexible type of kegerator. If you only plan to use one system or the other, you don't have to make it as complex as we are. It'll cut down on your cost a little bit, but what we're going to show you allows you to work with almost any kind of beer you're likely to come across. I'll go through all parts of the gas side and just sort of demonstrate what all the components are so that you have a sense of what you'll be dealing with. The first step, or the first component in the gas system is the cylinder or tank, and that's what holds your carbon dioxide. It's filled with liquid CO2, and that allows the tank to hold a lot more than if it were just gas in here. Then when you open the valve on it, the pressure drops and it allows gaseous CO2 to escape, but it's at a much, much higher pressure than you would ever want to use with beer. So you use a regulator to drop it down to an appropriate pressure. So you have high pressure CO2 coming out, then there's a little diaphragm inside that regulates the pressure and allows it to exit through this port. Now this is a little a screwdriver screw, and you just use a flat head screwdriver on that to adjust the pressure. There are some models that also feature a dial. This also has an integrated pressure relief valve that you can use to manually relieve the pressure. There's also an automatic pressure relief if it exceeds the capacity of the regulator. So these are pretty safe devices. On the outlet here, there is a valve that you can either use to kill the gas or allow gas to flow. There's also an integrated check valve inside of here that only allows gas to go out. So if for some reason beer were ever to try to go back up, it'll prevent that from happening. You have a length of flexible tubing. And then on the end here, you have a gas disconnect. And this is for a pin lock keg, gray for gas. You'll see on the end here, in between the disconnect and the tubing, we have this little swivel barb here. So if I just unscrew that, it allows us to use this system with many different types of kegs. These disconnects for pin lock and ball lock all have these what are called MFL connectors on them. You can also buy these with barbs on them, just like these. This is an MFL connector that converts this to a barb. The barb is what goes onto the hose. So if you're only going to use one type of keg, you can save some money and make it a little simpler by simply getting the disconnect you need with the barb on it. But for our purposes and for maximum flexibility, we're going to use these MFL swivel nuts. So you can connect a pin lock disconnect to it, you can connect a ball lock disconnect to it, or you can connect a commercial keg to it. This is a tailpiece that replaces the standard tailpiece on a Sankey coupler that you use on a commercial keg. It's designed to fit into this as well. So by using this system, you can use virtually any keg in your Kegerator. In the system we're going to build, we won't just have one keg, we're going to have several. So rather than connecting this directly to one of these disconnects, we're actually going to connect it to this distributor. The distributor simply connects to the end here, and then it distributes. It's a manifold inside, and it allows you to shut off and turn on gas to any of the lines. So in this position, all 6 of these lines would be off. And then if we only had 2 kegs going, say, you would just turn those on, deliver gas to the 2 kegs, and this prevents leaks from coming out on those other ones. So this is a handy way to distribute gas among many different kegs. This solution does require that all the kegs be served at the same pressure because this has an identical pressure all the way through. If for whatever reason you were planning to serve different kegs at different pressures, then you would need to have a secondary regulator, in which case this would actually split, and you would have one branch of it going at this pressure. The other side would then connect to a second regulator that dials down the pressure even further. So you might imagine on the high pressure side, maybe you would be serving a Belgian ale or a Hefeweizen or something that requires a higher level of pressure than, say, British bitter, which is served at a very low pressure. So in that case, this would serve your Hefeweizen, then the other branch attached to the secondary regulator would be used to serve your bitter. The Kegerator we're going to show you how to build uses the same pressure throughout. That's what most homebrewers and commercial enthusiasts do. It's the simplest option, but there is that option of doing a secondary regulator if you so desire. We'll discuss the gas side in more detail later in this course, but suffice to say now, the gas serves 2 purposes. It both carbonates beer, if it's uncarbonated to begin with, if you're a home brewer, for example. Already carbonated beer, it maintains that carbonation, and then it also pushes the beer. So it pushes beer out of the keg and through the faucet into your glass. So we'll go on to the liquid side and discuss those components. So just to review, everything up until this point has been for one side of the keg, gas in. Now we're going to talk about what happens on the other side when you have liquid coming out. There's a long dip tube inside the keg, regardless of what kind of keg you use, and the pressure inside pushes liquid up through the dip tube. It exits through one of these disconnects, black for beer. So there's the ball lock, and there's the pin lock version. The end, again, in our case, is going to connect to one of these MFL swivel nuts. Again, if you chose to go ahead and just buy ones that have the barb on it, you won't have that step. The end of the barb goes into some beverage tubing, and we use a clamp to hold that down. And then the beer will travel through the beverage tubing to the faucet assembly. And the faucet assembly is exactly what it sounds like. It's everything that is necessary to get beer out of the beverage tube and through the faucet. There are a few different ways to do it. The shank and faucet is what we're going to show you. And this is what you don't see when you go to your favorite bar. This is the bit that you see with a faucet attached to the end. But behind the faucet, there's this long shank. And what happens is you have a tailpiece and a hex nut and a washer that connects the beverage tubing. So here's the end of the shank. And then to prevent leakage, you have a washer that goes on the end, and then a tailpiece that just is a fancy name for a barb that sits on top of that, and then a hex nut that holds it all together. You tighten that up. This connects to the other end of your beverage tubing. So now you have beer that goes through the shank, through the wall in the case of a bar, or in our case, through the wall of our kegerator that we're building. If you run a draft tower setup, you'll be using a much shorter shank. Some of them actually have a curved barb on the end because the space inside of a draft tower can be a lot tighter. But in this case, we're using a fairly standard 4-inch long shank. The end here, there's a collar, and this little collar is what tightens the faucet. Faucets come in different varieties. The ones we're using today are forward seal faucets. The forward seal faucet has some nice advantages. There's a higher upfront cost, but in the long run, I think you'll be happy if you purchase these. They use a special design that actually prevents the beer from being exposed to the air. So in a bar, when you're pouring pints fairly often, almost continuously, there's not enough time for the beer to really get sticky. But at home, maybe you pour a couple pints in the evening and you don't do so again till the next day. The standard faucets might allow that beer to get sticky in there, and it can get kind of gross. But if you use these forward seal faucets, that's never an issue. And they have all faucets have a standard little notch pattern that just fits onto the end of the shank, holds it in place. And then the collar slides right up onto the end there. And this will look a lot better when we're actually putting it into the keezer. But the collar then just screws it into place. There's a special faucet tool that you can use to tighten it even further. But that then is how beer gets out of the draft system. Little lever there. You can attach a fairly simple handle to it. You can use one from your favorite bar. You can design one yourself. There's a bunch of different options there. So this is really the essence of how beer gets out of the keg. And this is the liquid side before the beer hits your glass. One thing every draft system has in common is some means of refrigeration. If you are at a party, it might simply be a bucket of ice. But at home, you're going to have a fridge or a chest freezer or some other way of keeping your beer cold. If you're using a pre-purchased kegerator, that's already taken care of for you. But if you're building your own system from the ground up, then you have to decide what works best for you based on what'll fit in your house or where you plan to put it, how you want it to look, and how much you're willing to put into it. In this case, we're going to build what's called a keezer, which is a combination of the word kegerator and freezer. So what we're going to do is take this perfectly good chest freezer and we're going to take it apart and then put it back together with the right components to dispense beer. You can buy one of these brand new, or if you search on Craigslist, you can pick one up for fairly cheap. Might even be able to get a free one from a relative or someone who's getting rid of one. They're usually pretty easy to come by. The newer models do have more energy efficiency, better insulation, so take that into consideration when you're thinking about what type of refrigerator to use. at my house, I use a small dorm fridge that I converted with a draft tower on the top because that's what fit in my house. I wouldn't really have room for one of these in the house, so let that guide you as well. And with that, let's get started taking this thing apart and converting it into our Kegerator. One thing to think about whenever you are designing your home draft system is whether you really need to design one in the first place. If you only plan to serve one keg, it may be more cost effective for you to simply purchase a Kegerator that's ready to go. Those typically start at around $400 or so, and you don't have to spend any time or buy separate equipment. It's all ready for you to use. The advantage of using a custom-made system really starts to show whenever you want to dispense more than one keg. In this case, we're going to be dispensing 4. And to buy a commercial Kegerator that dispenses 4 kegs, you're going to spend a lot more money on that ready-to-go solution versus building one yourself. In any case, you're going to spend a few $100s on a project like this, so definitely take that into consideration whenever you're looking into designing your draft system. Once you've decided that building your own system is the way that you want to go, then you need to decide whether you want a Kegerator, like we're going to build, that uses a chest freezer, where we're going to override the standard temperature control, or if you want to use a refrigerator, which in that case you may be able to simply use the built-in thermostat, depending on how good it is. They both have their relative merits. The refrigerator solution, the refrigerator is all ready to refrigerate and not freeze, so you have that in your favor. The geometry, if you have a bad back or something and you don't want to lift kegs to put into a freezer like this, that might be a better solution. One disadvantage of a refrigerator is that every time you open the door, you're going to allow cold air to escape, whereas a Kegerator solution like this that has a lid that opens, it keeps more of that cold air inside the space whenever you're opening it up. So you just have to weigh those different options whenever you're deciding the system that works best for you. The other advantage to a system like this is we're going to modify it such that we don't actually have to drill through any of the hardware on the unit itself. If you are modifying a refrigerator, you'll need to drill through the door and potentially other parts, in which case you don't want to hit refrigerant lines. If many people who convert, say, a little dorm fridge and put a draft tower on top have to do some work to figure out where exactly the refrigerant lines go so that when you mount the tower, you're not actually puncturing any of the lines and rendering that refrigerator useless. So with all of that said, let's get going on our Kegerator conversion. This is a fairly common 7 cubic foot chest freezer, and we're going to override the standard thermostat that will have it, the set point around 0 degrees Fahrenheit. And we're going to have the external thermostat set at about 38 degrees Fahrenheit, so that this thing will not actually freeze, but will instead refrigerate our beer. The first thing we're going to do is install what's known as a collar. And the collar is going to be a piece of wood that sits between the factory lid and the body. And the reason we need that is that we actually don't want to drill through any parts of the body on this chest freezer and potentially hit a refrigerant line. It's also going to give us a little more space, so it's going to raise the lid up a little bit, have a little more room for our components, and it'll give us something that we can drill through to install the faucets and some other things that we're going to need for our Kegerator. I've already taken the screws out on the back here, but essentially we just had these little machine screws like this, and there were 4 of them per hinge. And all you do is take those out. Be really careful with these hinges. They're designed to hold the lid up, so they're really strong springs in there. So you just want to pop that out. Same thing on the other side. I'm going to just pop that out. And that allows you to remove the lid so that we can install our collar. Now the collar that we're going to install, we've actually pre-built it, and we made it just out of some pieces of lumber here. All you need to do is buy the appropriate pieces of lumber. You can cut them yourself. And these are just some angle brackets that hold them together. And we sized it so that it sits right on top of this. And in our case, for now, this is just going to sit right like this. There are various ways of attaching the collar to the base of the Keezer. If you want to maintain the integrity of your chest freezer in case you maybe want to sell it someday, upgrade to something else, then you might look into what some brewers do is actually attach another piece of wood on the outside all the way around so that when this thing sits down, it's actually constrained and held in place by another piece of plywood or something that's sitting on the outside. That also gives you some flexibility to stain it and make it look nice. If you don't mind destroying a little bit of the original finish, then you can certainly apply an adhesive along here. There are lots of ways to do that. You might sand this down and use some epoxy. There's lots of different options. For our purposes today, we're just going to leave it like this for demonstrating how to work with this, but ultimately you do want to have some way of securing this down. Now we've already drilled some pilot holes on the back here. I'll turn this around so you can see. All we did was just sort of trace the outline of the hinges that we had there, and we're just going to use that as a way to install the lid. So the collar's here, the lid sits on top of it, and again, when you actually build your Keezer, you want to make sure that you secure the collar in whatever way works for you. And then it's just as simple. You snap that down. Like I said, those springs are strong. There we go. Kind of get it into place there. You want to kind of loosely install the screws first. Don't tighten them all the way down. That way you'll have a little bit of play. We're going to install some weather stripping that will help maintain insulation. So we want to have a little bit of flexibility to do that. So we've taken the machine screws out to get the thing back on. We just need to use these wood screws. They've got a little washer there to kind of hold it in place, and then, of course, a different thread pattern to really grab into that wood. So all we're going to do is just use our original hole patterns and let her rip. All right, that's the last screw. Got the last one in there. So now our lid is securely attached to the collar. And the next thing we're going to do is put a little weather stripping in between the collar and the main body of the chest freezer. Like I said, there's a lot of different ways you can attach the collar. In our case, we want to be able to maybe turn it back into a freezer at some point. So we don't want to use anything terribly destructive. So we're just going to use a little bit of weather stripping that was originally intended for use with an RV. So I'm just going to take this whole thing and turn it over, and we're going to attach the weather stripping to this. And again, if you don't mind dedicating your chest freezer to one purpose, you can certainly use permanent methods. So I'm just going to roll this out. Just right along the edge. And then give it a clip. And you can trim that up in a bit, but make sure it's nice and secure. And then this stuff just lifts off, and it's a nice kind of rough surface there. It'll provide enough friction for now to hold the collar in place. Eventually, we're going to place some wood around it to hold the collar in place, but while we're working on it, we'll just use the weather stripping for now. This will also provide a little bit of insulation so that there's no air leaking between the body of the Kegerator and the collar. So, got the last piece of weather stripping going on right now. And that should do it for our insulation here. So we used this 1.5 inch weather stripping here because we used 2x6s on our collar. You could use 2x4s if you didn't want it to stick up quite as much. The nice thing about this 1.5 inch weather stripping is it almost exactly fits on the 2x4, which is not actually 2 inches, but rather 1.5. So that fits nicely in there. It's thin enough that it provides insulation, but it's not so thick that it's going to hold the thing up too far off the top of the Kegerator. So then we'll just take it and flip it back upside down, and it should just kind of fall into place. And again, we're eventually going to use some boards around the sides to hold it in place, but while we're getting things adjusted here, this is going to provide just enough friction to hold the lid where it needs to be. So now we have the collar in place. It allows us to open the lid and close the lid and have a nice insulated area around the side here that holds it up off the main body. Wood is actually a great insulator. If at some point you feel like you need more insulation, then turn this around here. Then there's plenty of space right down in here. You can always add silicone sealant. That's one thing you can do to close up the air gaps. If you have large pieces of styrofoam insulation, you could kind of tape those or glue those in here and run some other boards along. But the wood itself is actually such a great insulator that we're just going to start with this, and it'll probably be just fine, and we'll see how it goes if we need to add anything down the road. Now that the collar's in place, our next step is to drill the holes for the shanks that are going to carry the beer out of the lines and into the faucet and ultimately to the glass. These shanks are slightly less than 1 inch in diameter. So what we have is 1 inch wide Forstner bit here. And we've already spaced out, ultimately this Kegerator, this Kegerator is going to have four draft handles. And we spaced them about 5 inches apart here so that when we go to install all of the drafts eventually, they're all going to have these little flanges on the outside. We'll have enough space for the faucets and the handles, and we'll have plenty of room to maneuver there. Today we're just going to install the first two, and we've already placed we've already put marks where we want the faucets to go, the shanks to go, and so the Forstner bit has just this little sharp point there on the end, so we're just going to line up the point with the mark. Get it right on there. And this particular bit also is designed so that it doesn't splinter a whole lot. So with that in place, I'm just going to give it some gas. Success. We made it through to the other side. And so there we've got a nice round hole for the shank to go through. And if we played our cards right, that shank will just fit right through there. And it does. So We'll repeat the process with the second hole and then show you how to install those shanks. Our collar's installed and we have the 4 holes drilled for our 4 draft lines. And now I'll show you how to install the shanks and the draft lines. So again, the shank is what carries the beer through the wall of the collar in this case, or if you're at a bar, through the wall out to the bar itself. So you have the shank and then the little collar bit that will connect the faucet to. There's also this little flange that sits on the front. So we'll thread that in first. And then there's a little hex nut that goes on the back and we'll secure it into place. All you do, and this is the same whether you're using a collar like this or going through a refrigerator, just get it in there and thread the hex nut on. In this case, we'll just hand tighten it, but you can get a box wrench and really tighten it down if you want to. So get that on there. There we go. If you are working with a draft tower, then this shank will be much shorter, and working with that hex nut can be a bit of an issue because of the constrained space within the draft tower. In those cases, you can buy a special tower wrench, or if you have a Dremel or some other type of rotary tool at home, you can buy a standard box wrench and just cut off a couple of the sides of it. The idea is rather than a full closed loop, you have more of a claw that you can get around inside the draft tower to manipulate it. But in this case, it's nice and easy. Just kind of fit it on there. So the shank is in place. The next step is just to add the washer and the tailpiece. Again, the washer is there to prevent leakage. The tailpiece gets the beer in there, and the hex nut makes sure it stays on. Just connect that up. Again, you can use a wrench if you want to tighten that down. And then we need to attach a draft line to that. Now in our case here, we're using what's called barrier draft line, and really recommend that over the standard PVC. Most Kegerator kits will come with this fairly standard PVC draft line. It's called Bevlex, and it's great if you work in a high throughput location like a bar. If you're planning to let your kegs sit at all for a day or two between pours, then there's the chance you might get some flavor coming from the line. So this line will help prevent that. It also has an antimicrobial lining in it so that it won't get bugs growing in it if it sits there. And it's nice and flexible. Some of the lines can be a little stiff. This is a nice flexible line. So it just slides onto the barb. You might have to work it a little bit to get it on there. And if it's being really stubborn, you can get some boiling water or even a heat gun if you're really having trouble with it. But usually enough finagling will just get it in place. I already have a hose clamp ready to go. Make sure you always tighten down these connections using a hose clamp, particularly because you have such high pressure going through these lines. You really don't want to pop a hose at any point and end up with beer all over the place, especially if it's beer that you brewed, because that is a lot of time wasted. So we'll just tighten this down. You can also use what are known as Oetiker clamps. They're a stepless clamp, but they require a special tool. For most applications, these worm clamps are just fine. And just kind of, get it tightened down on there. But even if the fit is nice and tight and you think you don't need a clamp, you still need a clamp. Don't ever avoid putting clamps on these things. So, clamps nice and tight on there. The other end of our beverage line is going to go on to the disconnect. Now again, in our case, we're using these nice little barbed swivel nuts. And if you don't want to bother with this, you can buy a disconnect that's already got those on there. I have one already connected to a pin lock quick disconnect here. Again, black means beer. This is our beverage line, so that's the right one. So again, you might have to force it a little bit to get it on there. There we go. Get it on there. Don't push it too far up, because part of the nice thing about these swivel nuts is that they actually do swivel. If you push the line too far up, it'll just stick in place, and then it's harder to work with. So now that that's in place, we'll just use our screwdriver to get the worm clamp in place, and then once the worm clamp is in place, we'll be ready to install the faucet. All right, so we have the worm clamp on there holding the line in place. Line length is something we will discuss in another part of the course. It depends on a lot of different variables. Essentially, the pressure that you're supplying to the keg is the same pressure that is appropriate for carbonating that beer or maintaining that beer's carbonation. But that may not be the exact right pressure for serving the beer. If it's too fast, then you need more line to slow the beer down by the time it gets to the faucet. And in this case, we're using 8-foot lines. A lot of the standard kits come with 5-foot lines. It's not uncommon to use even 10 or 12-foot lines, depending on the type of beverage line you're using in your particular setup. When we get to the bit on draft line balancing, I'll actually provide an equation for you so you can calculate the appropriate line length that you need to use. But in this case, we're going to use our 8-foot lines. We're going to have our pin lock disconnect, which will connect to our keg. And then we're ready to put a faucet on the front. And again, we're using these Perlick forward seal faucets. They're stainless. You can use chrome. Chrome is less expensive to start with. You can also use brass. Stainless will last forever though. Nothing will flake off. And so it's kind of nice to go ahead and use the stainless. And again, there are little teeth in there. They're going to grab onto the little teeth on the shank and can go a few different ways. So you just want to kind of get it on there and then rotate the little collar. And there's a tool you can use that you can actually grab onto the little holes with if you really, really want to tighten it down. It's called a faucet wrench. And then once you have your assembly in place, then you can attach the tap handle of your choice. These little guys don't cost very much. They're kind of nice for, sort of a modern look. And they're quite inexpensive. If you happen to have a friend who works at a brewery, or maybe you work at a brewery, you can get one of these nice big brewery grade tap handles to fit on there. They all use the same little threaded pattern, and then on the faucet itself, there's a little widget that moves up and down. So depending on how far this actually threads onto it, once you get it as far as it'll go, let's say that it just went that far, then you can actually just rotate that up to tighten it into place. And if we played our cards right, that should just clear the top of the keezer there. And so you just do that for each of those holes there, and each draft line will have its own faucet, shank, and beverage line, as well as its own disconnect. And now that we have the beverage line in place, I'm going to go ahead and add the second one, and then we'll show you how to do the gas side and get your first pint going. We've installed both of the faucets and both of the draft lines. The next step is to get the gas side up and working. And now what we're going to do is run all of our gas through this six-way distributor here. And if you're only running 1 or 2 kegs, you don't need to worry about one of these. But we have room for 4 kegs, 4 full-sized kegs, and up to 6 small-sized kegs. So we want to make sure that we have that future adaptability. So I'm just going to mount this onto the inside of the collar, where we've already got some pilot holes drilled back there. I'm just going to put that in place with some wood screws and start them with a screwdriver just so I have a little bit of flexibility, and then I'll finish them up using the drill. One. Put on the other side. All right, that distributor is on there nice and tight. Again, it's totally optional. If you put one in, it'll be great for us. It'll give us a lot of future expansion capabilities here. Now we need to attach the two gas lines that we're going to use. So remember, the gas from the CO2 cylinder goes through a regulator and into here. It's going to fill this chamber. All of these are currently switched off, and then we'll just make sure that these two, we're going to have gas lines. Now, if you can see on the end of these things, they have bare metal connections. And contrast that with the ends of our disconnects. The ends of our disconnects, this is a gas disconnect, has a little piece of plastic there. So when we thread one of those MFL swivel nuts onto here, this is going to seal it. However, with our gas lines here, because it's bare metal, there's nothing to seal it. It's just metal against metal. You could use Teflon tape. A quicker and easier solution is to use one of these little flare nylon washers. They're inexpensive, and they just fit into, these guys just fit into the little swivel nut, which then when it attaches there, it'll make a nice, tight, clean connection for the gas. We're ready to get the gas lines onto there. To make life easier, I'm just going to go ahead and attach this little swivel nut onto a gas disconnect. It'll just give me a little more leverage for attaching the line. Same as with the liquid connections, all you need to do is use a clamp and slide the end of the gas tubing right onto that. Gas tubing can be really any flexible tubing. 5/16 of an inch is fairly standard. We're using 1/2 inch OD, 1/4 inch ID on this. And again, we'll just make sure that it's nice and tight with a worm clamp so that we don't lose any gas. We got the end attached for our gas disconnect. That's going to go onto the keg. This other end is now going to go onto here, again using a swivel nut. One of these guys. Now what I'm going to do is actually take the disconnect off and drop the other side. This is just going to give me, again, a little more leverage for working with this swivel nut there. This is something to grab onto. So again, another worm clamp. Slide that right on. Again, not all the way, because you want to have a little bit of leeway there so that you can actually swivel it. And then tighten that down. So once the clamp is in place, now I can take, it doesn't really matter which end is which, but I wanted this end to go up there because it has slightly smaller worm clamp there, take up less room. So just put this back on the other end. You don't have to really mess with what I'm doing here, but I just like it for the extra leverage. Again, remember, there's a little piece of plastic on the disconnect itself. Some disconnects won't have them, usually they will. So usually you don't need a little washer on the disconnect side. You can wrench tighten it, or usually hand tightening is fine unless you're working with nitro, which we'll discuss in a bit. So this is going to get attached to the gas post on the keg. And now this is going to connect to one of our distributor ports. Remember, we want to use one of these little plastic washers to make sure we have a nice airtight connection in there. So just kind of get it in the nut and then get it onto the port and tighten it down. These you probably really should make sure you go ahead and use a wrench or something or some pliers to really get it nice and tight on there. So this is our gas line that's going to go to the keg. That'll switch it on and that'll switch it off. To supply gas to the manifold here, we're going to take our CO2 tank and distributor and just attach it to the end there. So here's the tank that I showed you before. Now you can keep these inside or outside of your kegerator or keezer. It really doesn't matter. In a keezer like this, there's enough room, it can just live right inside. My mini fridge at home is pretty tight on space, so I actually keep the tank outside and run the line through the drain hole, and that frees up some space and allows me to fit the kegs a little bit better. But this one, we're just gonna let it sit inside of the keezer and take the other end, and this one's on there a little tight to actually swivel it, so I'm actually just going to loosen that a notch or two and try to pull that out a little bit so that we have some room to maneuver. That's why you don't want to get those on there get the tubing on there too far, otherwise it can be hard to swivel. Now again, here we have a bare metal connection inside, and we have a bare metal connection there. So I want to go ahead and use another one of those nylon washers to ensure a nice airtight connection there. So then that we'll just screw onto, actually I guess it is still on there pretty tight. Go. I've intentionally left some of the connections on the liquid side here just a little loose so that we can maneuver a little more. But on the gas side, you really do want to tighten everything down nicely. So just make sure that all of those gas connections are good and tight, because the worst thing that can happen is to have your gas cylinder run out when you're trying to serve your beer. I've tightened this down nicely, I've tightened this down nicely, and just to make sure, I'm gonna even tighten the disconnect down nicely, because you just don't wanna lose any of your precious CO2. Particularly true when you're working with nitro, which we'll get to in a bit, which costs quite a bit, so you don't want to lose any of that. So our gas system is in place, the liquid system is in place. Now I'll show you how to hook it all up. The idea is the same, whether you're using a pin lock keg, a ball lock keg, or a commercial keg. In this case, I'm going to show you how to do it with a pin lock keg. It'll just go into your keezer. Obviously, there's no beer in it. It's nice and light. And remember, gas is gray. It has two little slots on pin lock, and beer is black. It has three little slots. And so we'll connect, doesn't really matter which order you connect them in. That is now ready to serve. It would be the same if you were using a ball lock keg. It would be a little bit different if you were using a commercial keg. Remember the little tailpiece I showed you earlier. On a commercial keg coupler, you have one of these for both the gas in and liquid out, but it's on the same coupler. So you'll still have the two lines, but instead of going to two different disconnects, the lines will both go into the same coupler using one of these little adapters, but it would snap into the keg just as you would any other commercial keg. So we have our keg here. We can, in this setup, we can fit 4 of these full-sized kegs. We also can fit some of the little smaller kegs. And really, you just have to look at your space, see how everything's going to fit together, and choose the configuration that works best for your particular setup. Talked a little earlier about balancing your system, about line length, and we want to go into that in just a little more detail. The CO2, like I said, serves two purposes. One, it carbonates your beer. So if this is your keg of homebrew that has not yet been carbonated, the keg or the CO2 will do that. But if you're even serving commercial beer, you still need to have a CO2 source. If you were to slowly empty that keg over a period of time, by the end it would go flat. So you do need to continue applying CO2 the whole time. So that CO2 is primarily there to keep the beer carbonated, but it also pushes beer through the lines. Now, if you're in a bar, in a professional draft system, sometimes your keg may be in the next room over, in which case you might have some pretty long lines, and you might not be able to use CO2 purely to push beer. You might actually have to use a blend of CO2 and nitrogen. Most homebrewers don't need to have lines that are quite so long, but you do need to make sure that your lines are long enough to provide enough restriction so that you don't end up with a glass full of foam. Carbon dioxide is very soluble in beer, whereas nitrogen is not. So if you are working in a professional bar setting or a brewery, you may use a blend of nitrogen and carbon dioxide. What that allows you to do is to have the pressure needed to push the beer through the lines. You can serve using a higher pressure with nitrogen, but based on the amount of CO2 present in that blend, that's how much carbon dioxide will actually get absorbed into the beer. As a home brewer or running a home draft setup, unless you're running a nitro setup, you're going to be using pure CO2 both to carbonate and push the beer. So you need to ensure that the lines are appropriately long to offset whatever carbonation pressure you're using for the beer. Now, a typical carbon dioxide setting on a cylinder like this, you might set it to anywhere between 10 and 15 pounds per square inch for carbonation purposes. That means that you're going to be running 10 to 15 pounds per square inch of CO2 through those lines into the keg, and that's what's then pushing through the beverage line. If you don't have enough line length, you're going to have beer coming really fast out of the faucet. And as it does so, it's going to knock a lot of that CO2 out of suspension, so you'll end up with a glass full of foam, and even if you let that foam settle, it'll be pretty flat because all the CO2 will have come out of suspension. So what you want to do is select a line length that just offsets the pressure, so that when you pour a pint, it's just coming out of the faucet, not too fast, not too slow, and you get a nice head of foam on top, but not a pint full of foam. So the way you choose a line length, and again, we'll provide you with an equation to figure this out, but you know what the carbonation level is in your keg based on the beer style that you've brewed or are serving. Commercial beer in the US is almost always served at 2.6 volumes of CO2. And what that means is if you took, say, 5 liters or 5 gallons rather of beer and allowed it to come up to room temperature, that CO2 would expand to fill the same volume 2.5 times over. So 2.5 volumes would mean you'd have 2.5 times the volume of CO2 if it were taken out of solution. So 2.6 is what's typically used in the US, and if you're carbonating to 2.6 volumes and serving at 2.6, or the pressure needed to maintain 2.6 volumes, that's usually going to mean somewhere between 10 and 15 psi. So that's the first factor, is how much pressure are you applying to the keg just to maintain carbonation. That'll influence how much line length you need. The next is the vertical rise. So in our system here, we have faucets that sit maybe a foot or so above the top of the keg. Well, it has to, the beer has to fight against gravity as it's moving upwards. So gravity is taking some of the momentum out of the beer as it flows. So you can actually take off some of the pressure based upon how much gravity is actually pulling on it. Elevation figures into it. In Fort Collins, where we're based, we're at about 5,000 feet above sea level. So we actually need a little more pressure to maintain the same level of carbonation as you would at sea level. So because we're at a higher elevation, a little more pressure, that means a little more line is needed. And there's also temperature. Temperature is also a component because the temperature directly affects how much CO2 is absorbed into solution. The typical standard serving temperature for beer in the US is 38 degrees Fahrenheit. So if you use the calculator that we're providing for you, you can simply plug in the temperature, plug in the serving pressure based on the carbonation level of the beer you're serving and your elevation and how far your faucets actually are above the keg, and it will give you an estimate for how long a line length you need. In this case, we're using 8-foot lines. I run 12 feet at home, and most standard Kegerator conversion kits will come with 5. So you may find that you need to purchase additional line based on the balancing of your own particular system. We've assembled all the major parts of our Kegerator. We have our draft system in place, the draft lines are there, the kegs inside, and the gas lines are all in place. If we were to just plug this in as it is, though, we would eventually get frozen beer. If you have modified a refrigerator, or if you're running a dedicated Kegerator that you purchased already, then there's nothing else you need to do. Those are already ready to run at the appropriate temperature. My Kegerator that I have at home, it's based on a dorm fridge, and I don't use a temperature controller with it. With a Kegerator, on the other hand, you need some way of regulating the temperature so that it doesn't freeze. And so you use a temperature controller for that. And all a temperature controller is it's a device that senses the internal temperature and turns, in this case, the chest freezer on or off to maintain that temperature. This is one called the thermostat. It's actually a dual stage. You can use it for regulating temperatures of fermentation. That's why it has both a cold side and a hot side. You can run a fridge or a heater with it. In this case, we'll just use it to run our chest freezer. So the temperature controller itself plugs into the wall. And then we have the cool line here. The end of it is an outlet. And rather than plug the chest freezer straight into the wall, we plug it into the controller. And then this will turn the freezer on or off depending on the temperature that it reads. And the way it reads it is with one of these flexible temperature probes that you can really just slide in to your freezer. So just open it up, and in this case I'll just throw it down in there and close the lid. There are various ways you can sense the temperature inside the chest freezer. Some people just let the probe dangle inside and measure the temperature of the air. That's one way to do it. It's not entirely the best way because air is such a poor conductor of heat relative to water or to liquid. So a better way of dealing with it is to actually immerse, assuming that the probe that you use is waterproof. Immerse it in a bucket of water, or some people use a water bottle filled with water. Some people even empty out the little gel packs that you use to ship liquid yeast and kind of create a permanent solution using that. Just make sure it's in something that it won't be kicking the compressor on and off quite so frequently as if you just left it inside. But then all that's left to do once you have the probe inside the Kegerator is just to dial in the actual temperature that you want to maintain here. Again, in the US, that's typically 38 degrees Fahrenheit for commercial beer. As a home brewer, though, it can be whatever you want. If you tend to like brewing light lagers, then you're probably going to want to serve those closer to the 38 degree side. If you prefer stouts and British pale ales, you'll probably want to serve those a little bit warmer, maybe as high as 55. And the controller really gives you the flexibility to do that. You can also use one of these with a regular refrigerator to override the standard thermostat, and that really depends on the fridge that you're using. Some fridges can maintain a really precise temperature based on their own internal thermostat, but you really need to put a thermometer in your fridge to see how well it does. So many people do end up overriding their refrigerators anyway. So once the controller is in place, all you have to do is wait for your beer to cool down to the right temperature, and then you're ready to serve. So we've shown you how to build and maintain your own personal home draft system that uses CO2. A lot of brewers at some point get interested in pouring with nitro. And if you've ever had nitro beer at a bar, you know it's quite the show, and it can be quite impressive. And with the right beer style, it can be very, very good. Nitro is a whole other setup, but you can use a lot of what you already have. What you'll need to pour nitro beer is basically three things. You're going to need a new cylinder that is specially rated for high pressure gas like nitro. Nitrogen doesn't really liquefy under pressure, at least the pressures we use, the way that carbon dioxide does. So rather than have a liquid in the cylinder the way that you do with carbon dioxide, they actually just cram as much in here as they can under high pressure. So there's really high pressure nitrogen in here. And it's not really just nitrogen, it's actually a blend of nitrogen and carbon dioxide. It's called beer gas, Guinness gas, I think I've heard it called G gas as well. It's usually about a 75% nitrogen, 25% carbon dioxide blend. The good ones will come with one of these safety caps. Because you are dealing with such high pressure, it's a good idea to have one of these, but that just protects the valve on top while you're transporting it. You can get your carbon dioxide filled at many homebrew stores, paintball suppliers, and so on. Nitrogen, you may need to go to a specialty gas supplier. If you live in a town that does have a large number of breweries or beer bars, you just need to ask someone who works at one of the bars where they get their nitrogen filled, and you might be able to get that done as well. So this is a nitrogen cylinder. One of the things that you'll notice is different about a nitrogen cylinder versus the CO2 cylinders is that it has a female output rather than male. The regulator is also different. So it has a male connector to the valve there. It's also rated to a much, much higher pressure. So, the scale here goes as high as 3,000 PSI, which is really quite high. Because the connectors, though, are different, there's really, unless you go out of your way to try to get around it, there's no way to connect a nitrogen regulator to a CO2 cylinder or vice versa. So there's never really any danger of mixing up the two. So the regulator just connects to the cylinder the same way as you would, your CO2. Got threads in there. So it just connects as you would anything else. It's a right-handed thread, just like CO2. And this one's worth tightening up with a wrench. For demonstration purposes, I'll just hand tighten it here, but really you want to use a wrench to really lock that down. Same thing as your CO2 regulator. There's a little screw on the front that allows you to adjust the pressure. We talked about the line length and how most CO2 dispensed beers, you're going to have about 10 to 15 pounds per square inch of carbon dioxide. With a typical nitrogen beer, you're going to have 30 pounds per square inch or more of the nitrogen CO2 blend. And there's a reason for that. Nitrogen systems were invented as a way of mimicking the same sort of texture and properties that you would get from a traditional British hand pump. And if you've ever had cask ale, cask conditioned style British beer, they use a hand pump, and the person operating the pump generally is applying about 20 to 30 pounds per square inch of force. Now, if you tried to use that much carbon dioxide to push your beer, ultimately it would become overcarbonated, and you just get a pint of foam. By using a blend of nitrogen and carbon dioxide, the nitrogen doesn't really dissolve into the beer very well. It just pushes it at a high pressure. The carbon dioxide, on the other hand, dissolves quite readily. So if you're pushing at, say, 30 psi, but only a quarter of it is carbon dioxide, then you're looking at about 7.5 psi of actual CO2, which is about right for a lot of British ales that are meant to be low carbonated. So you have your high pressure nitrogen cylinder, your high pressure regulator. You can use the same sort of gas setup as you would for CO2, just really make sure everything's nice and clamped down. This quick disconnect connects to your keg just like a CO2 disconnect. On my system here, I do have a quick disconnect right in the middle of the line. What that allows me to do is swap this out with a CO2 tank. So I just leave these connected inside my kegerator at all times. And if I want to dispense CO2, I have one of these attached to my CO2 cylinder. Or if I'm dispensing nitro, I just snap it in and I can use the same lines. So I've disassembled a stout faucet or nitro faucet here to show you what goes on inside and why you need one. If you open one up, there's this little restrictor plate. And if you can see, there are 5 little tiny holes drilled in it. And when you run high pressure gas onto the beer and push the beer through at 30 psi or more, when the beer goes through those little holes, carbon dioxide gets knocked out of solution and forms really nice small bubbles because of the high pressure. And that's what gives you that nice frothy, creamy head that you expect with nitrogen poured beers. So the restrictor plate is one part, and actually, if you leave this out, the stout faucet becomes a regular faucet just like any other. So if you do decide you want a permanent stout faucet and you don't want to dispense with nitro all the time, just take the restrictor plate out. Then there's also this little flow straightener. It's just a little piece of plastic. When the nitrogen and carbon dioxide blend hits that plate, there's all kinds of turbulence that pops up. So this just helps quiet that down so that you get a nice pour out of the faucet. So this is the nozzle, it goes on the bottom. So to reassemble it, you just drop the flow straightener into there. And then the restrictor plate goes right on top. And then there's a little O-ring that keeps everything from leaking. And that just sits right inside. Sometimes you have to kind of jam it down in there. And then this again is just like any other faucet. And the nozzle screws onto there. There's another O-ring just to keep it from leaking. And once you have that reassembled, the pattern on the back of this is just the same as any other faucet. So I'll take one of our tap handles off here, move the faucet there, unscrew that collar, put the stout faucet on. Again, just lines up the little notches, screw that back on, and then if you run a high pressure nitrogen CO2 blend on the keg that's connected to this draft line, you can serve using a stout faucet. The only thing to know differently about serving with a stout faucet is that there's a 2-stage pour. The first stage, you just flip the nozzle handle all the way forward until the beer is about 2/3 of the way full. Flip it back up, wait for it to settle a little bit, and then push back on the handle to top it up. And then you're ready to go with your nitrogenated beer. Whether you built your draft system from scratch, like we did, or whether you purchased a ready-to-go kegerator from a store, at some point you're going to run into some issues you'll need to troubleshoot. By far the most common one is foamy beer. And foam can come from a lot of different things. What it ultimately means is that CO2 is escaping from the beer when it shouldn't be. So if you have foamy beer, the first thing to do is check the temperature of your beer. So pour the first pint and take its temperature. And then pour the second pint and take its temperature. If they're different, then you may have a temperature issue within your refrigerator or keezer. Cold air settles and tends to stay put. So If you don't have some means of moving air around, then you could get temperature stratification within your system. It could be as much as 10 degrees colder at the bottom than it is at the top. And as that beer moves from bottom to top, it warms up, CO2 comes out of solution, and you get foam. And the problem's even worse if you have a draft tower. So if you're running a small dorm fridge or kegerator that has a tower on it, the tower usually isn't very well insulated, and so it might be 20 degrees higher up inside the tower. So temperature is the first thing to check. If you find that you have a temperature issue by comparing the different pints on the first and second pour to what you expect based on your temperature controller, then the easiest thing to do is to install what's called a muffin fan or some other kind of mechanism for moving air around. Muffin fan is simply, it's the same as a computer fan, and you can find them, maybe you even have one lying around in an old computer, or you can get them at a parts store, computer parts store for next to nothing. Wire it up and plug it into the wall. You can mount them with an accuser in a lot of different spots. I've seen systems where people will mount them, if you don't mind destroying part of your accuser, I've seen them mounted up here. I think probably in a situation like this, the best place to mount would be, somewhere on the collar, maybe a little bit offset. It doesn't have to be anything fancy. All you really want to do is get air moving around, because otherwise it'll tend to settle at the bottom. The cold air will. If you're using a draft tower setup, you can mount the fan at the bottom and use some flexible tubing, direct that up into the tower, and you'll actually push cold air up into the tower. Another way to do it is to mount the fan high and have a tube that extends to the bottom of your kegerator, and it'll draw air up and push it out over the top. Either way, you just want to keep air moving around. The temperature is the first thing to check. If after you've fixed your temperature issue, you still have foam, the next thing to look at is pressure. The serving pressure and the temperature dictate what length of line that you need. If you're finding that you have consistently foamy pours on the first, second, third, fourth, fifth pints, then it's probably a pressure issue and not a temperature issue. If that's the case, then looking into longer lines is probably your best bet. Ideally, it should take no more than about 6 seconds or so to pour a pint. If it's taking 2 to 3 seconds, then you probably have lines that are too short. If you have beer that takes more than, say, 8 or 10 seconds and is really slow coming out, then the lines are probably too long and you need to back off on that. When you find that you have a problem with line length, it's always much easier to shorten lines than it is to add lines. I wouldn't recommend splicing 2 lines together. So if you find you need longer lines, err on the side of extra long. Go as long as you think you need and then maybe a foot more. And then if the beer is coming out way too slow, you can always cut back on the line. It's much harder to add line once you've put it in there. Once you've looked at temperature and pressure, there are a couple of other things that could lead to foam. If your lines tend to roller coaster, if they kind of go up and down inside the kegerator, that creates spots where you could get nucleation inside of the lines and you could get CO2 coming out of suspension. You really want to always keep the beer heading uphill. You don't want it to go back downhill again. CO2 could come out at that point. And also check for kinks in the lines. Anything that restricts the flow in the line is a potential spot where carbon dioxide could come out of suspension. So always look for kinks in the lines and honestly dirty lines. If you don't clean your lines from time to time, then you might get some buildup. There's a phenomenon called beer stone, which is sort of like a kidney stone. It's calcium that builds up inside the line. And you can buy special cleaners. There's one called BLC, beer line cleaner. It's really easy to use. You just mix up a solution of it and run it through the lines, either pressurized in a keg, or you can buy a special device that just hooks onto the end of a disconnect, and then you manually pump cleaner through the lines. You don't have to do it after every beer, but I would say at least every second or third beer, definitely clean those lines out. And if you maintain the lines well, you probably shouldn't need to replace them for a long time, but plan on at least every couple of years probably changing out the lines if you use the Kegerator fairly frequently. Another place that you might run into some problems is, say you wake up one day and all of a sudden nothing's pouring. Your CO2 tank has run out. That can happen, especially if one that I've had hit me a number of times is between the regulator and the valve, there's a little O-ring. And carbon dioxide actually is somewhat corrosive to rubber. And so over time, if CO2 comes into contact with that O-ring, it will degrade it. And so you might find that one tank dispenses just fine, and then you have another one that maybe you hear a little hissing, or maybe you don't. Maybe you wake up one day and the tank's empty. Not to worry, if that happens, just go have your tank refilled. But then when you connect it back up, spray all of your connections. Pressurize the system and spray each connection with either some Star Sand solution or with a soapy solution, and look for places where there might be CO2 escaping. Generally, that's going to happen only at connections. It's very, very rare, unless you have something in your logger, or your Kegerator rather, that is rubbing up against the tubing. It's very rare that you'll have a puncture actually in the line, but it can happen. So that's another reason to really look at your system, look at the geometry, and make sure that the lines aren't rubbing up against anything, particularly if you're running a draft tower. Draft tower introduces a lot of opportunity for lines to touch stuff, and if you have enough friction over time, maybe you would end up puncturing one. But generally, if you check your connections, that should be sufficient. Whether you're kegging and serving your home brew or serving up your favorite commercial beer, having beer on draft at home is a lot of fun. And I hope that you've learned a lot in this course and are inspired to build your own draft system or go out and maintain one that you've purchased elsewhere. For more great information, definitely check out the website, beerandbrewing.com, for web exclusive content, and the magazine, Craft Beer and Brewing. In each issue, you'll find beer reviews, you'll find information about brewing your own beer, and about serving your home brew. So I hope you enjoyed these lessons, and let us know if you have any questions. Cheers.